This is the full sensor array in one module: accelerometer, gyroscope, magnetometer, temperature, air pressure, humidity and air quality, all on a single board. 7 sensors that individually would require 7 separate procurement decisions, 7 separate layouts and 7 separate I2C implementations. This board is what sensor fusion looks like before you write a single line of code. The motion sensors and the environmental sensors serve fundamentally different roles, and both are represented here. The BMI270 handles the high-frequency angular and linear data your fusion algorithm depends on. The environmental sensors provide the slower, longer horizon data for altitude correction, temperature compensation, and real-world context. Neither group is optional if you want a complete picture. The specific chips on this board were not chosen arbitrarily. The BMI270 from Bosch SensorTech is a co-located accelerometer and gyroscope, which means synchronized timing. The TMIG 5273 from Texas Instruments handles magnetometry. STMicro provides the pressure sensor. MEMS Vision handles humidity and temperature. Renesas covers air quality. These are production-grade components, not evaluation tier alternatives. All 7 sensors share a single I2C bus with dedicated addresses. This was a deliberate layout decision. Shared bus means one set of pull-up resistors, one pair of signal lines, one protocol to implement in firmware. Each sensor has its own address, so there are no collisions and no arbitration overhead. The wiring complexity you would normally have across 7 separate modules is eliminated at the board level. The module is 24 by 18 millimeters, that is smaller than a postage stamp. At that size, it fits in a drone frame without compromising center of gravity, on a wearable without adding bulk, and in an IoT enclosure without requiring a custom chassis. Compact form factor was a constraint, not an afterthought. Every component placement on this board was made to hit that dimension. Real-time environmental data means the readings are available continuously, not on a poll request cycle that introduces latency. When your platform is moving and the conditions around it are changing, you need data that reflects now, not 500 milliseconds ago. The sensor module streams all 7 channels at rates appropriate for each measurement type, and your firmware consumes exactly what it needs. The application range for a module with this sensor combination is deliberately broad: drone orientation and altitude, environmental monitoring stations, robotics with spatial awareness, field research platforms, industrial IoT with air quality compliance requirements, wearable motion capture, data network nodes earning daily rewards through verified sensor streams. One board, one integration effort, many deployment contexts.